Hey, David.
Hey Dan, how's it going?
Hi.
Hey, how's it going? Yeah, I didn't have anything specific. I was going to go through, uh, just start walking through the review of the ARM patches, and want to talk about the unlocked locked run transition and how we get the um, accept flow
Mhm.
into the path. Um, yeah, I feel like I wrote like an essay on that patch through. Hopefully that wasn't too much, but I was trying to get something on paper before for tonight.
So speaking of those transitions, Dan, there was one thing I was reading the spec, and it says that if the device enters the error state for the TDIF state, it can automatically transition itself to the unlock state. Do you know if the current proposed patch set is capable of handling that, or?
If the device transitions to the error state, that it automatically recover, or the kernel would automatically recover it.
Not
Back.
not necessarily. So the device itself, the spec says that the device itself has to enter the error state at some point, but it can automatically transition itself without operating system intervention to the unlock state after that. I don't know if
Um,
you're talking to him.
oh, sorry. Yeah, no, I was on mute. I guess what's the what's the issue? What's the issue with it transitioning to unlocked automatically?
It's just what I guess the operating system needs to be aware of its ability to do that, right? Because if it's in, so let's say an error gets passed down to the device, and then it automatically transitions itself to unlocked, but the, the kernel at that point would not have necessarily seen the error state because it could have automatically transitioned through it.
Yeah, I mean, I'm thinking that's okay because the error state will be um it, it's not like the error state causes the device to stop. I mean, like, so if it's a run state and it goes to the error, then it'll stop talking on the bus. But
Mm-hmm.
in terms of recovery, it's probably about the same amount of recovery as letting it cause problems
Yeah.
in the unlock state versus, yeah.
Yeah, I guess the issue is you potentially have, and this was something that I don't know if you remember Daniel Nemerov brought up when we were talking about TDX Connect stuff, that um, you basically need a way for the kernel driver to be made aware that at that point it's transitioned to the error state or to an unlock state. Otherwise, it could potentially start trying to access things, and then you have to handle kernel faults and stuff like that
Yeah,
instead of
I think what we are suggesting is the TSM framework should be plugged into the PCI error recovery,
Mhm.
which would actually which would actually be handling the TDIS error state transition, and then either the kernel will help the device move to the unlock state, or the kernel will know that the device automatically moved to the unlock state. So
Yeah.
whatever be the case, the TSM framework should have error handling in it, which it doesn't have right now, right? That's what.
Right, yeah. It doesn't have it now, um, but it seems like something that you makes sense to model with the
Mhm.
PCI error handlers, because it's kind of the same problem as going out of a security state is similar to losing a link or other kind of scenarios.
Yeah, it's just I wanted to make sure you were aware of it because we weren't made aware of it until recently. So it didn't come up until like a meeting that I had a couple days ago that you don't actually have to send an unlock to the device or to the DSM to get it into an unlock state. If it decides that it wants to, wipe all the data, the technical requirement is just basically that all confidential data has been cleared at that point, right? So if it does that immediately on entering the error state due to the way it's implemented, it could, in theory, just go straight to unlock without even hitting that error state.
I think actually we could simplify this these actions on software side because either in error state or in unlocked state, the host could always send the TDSP stop message to the device, and the device must respond. So actually, either stay in error state or transition to unlocked state, it is the device it is the DSM's decision. I think actually it doesn't affect the host side error handling process.
Okay. Yeah, that makes sense.
Yeah, I think the consideration is that if like a device, it's device decisions that to keep the secret on the device, so it stays in error state, but it keeps some secret in device in DSM. The other alternative decision is that it immediately whip out the secrets, and it could just go back to unlock state. So,
yeah, that makes sense. Because we were discussing this in the context of having a physical function level reset happen on the device. At that point, you could transition all the VFs straight to unlock instead of through error, as long as the physical function reset made sure that all the confidential data in the virtual functions was cleared at that point. So.
Oh, I was muted. But the expectation is that it's always the case that whether you transition out of locked, whether it's error or not, should be protective of secrets.
Yes. Yeah. Well, technically, in error, it can defer the clearing of the confidential data until unlock, but it could do it as part of the error state as well, technically.
I mean, but also whether it's cleared or not, it should still be, I guess, inaccessible through non.
Yeah, it should be inaccessible.
Yeah, it is still safe. So I don't think hosts have to do something differently on this point. Yeah.
Okay. I just wasn't sure if there was anything we had to account for when that came up.
But actually, I was going to ask for kind of jumped into the state thing, but I didn't kind of pull people for opens. Any other? Let me jump back. Ask for opens.
There is 2 points I wanted to kind of discuss with respect to the CCA changes I posted on patches I posted. One is even though we are not finalizing the guest interfaces, but I think TSM patch set, including some form of guest implementation saying this, we could rip this all out, right? It is good to kind of get the platform changes ready so that I can actually base all these things on top of upstream TSM v4, right? The challenge of not including, I understand from your email that you wanted to get the hosting sorted out before even getting into guest. But I think even if at a very hand-wavy level, having some guest kind of patches in the TSM framework, which is more which is more prone to changes, or which we may rewrite completely, is still good to get the rest of the patches ready from different architectures, right? That's one thing I wanted to kind of bring up. Yeah, sorry.
Oh, go ahead. Yeah, I mean, yeah, I mean, I think, I mean, I understand that. Yeah, and it'd be good to have the whole end-to-end going there. Um, I, let me take a look at that, splitting out
Yeah,
like
yeah,
the base TSM series versus stuff that adds these new features. But
yeah,
that's kind of the breaking point I'm seeing of like we can get the connect, because like the connect flow is something that Bjorn can sign off on. We can have like we can kind of put it to bed, and because Bjorn is not really going to care so much about the next
hmm
phase, which is the VFIO phase. So
yeah,
I
yeah,
was kind
yeah.
of hoping to just get rid of that. But yeah, but I see your point. Like we kind of want to move quickly to the point where all the framework pieces are there for everybody to
Yeah,
do their
even
end.
even if the guest can get rewritten, it's still okay, right? But having that, because I am not able to move to TSMV4 because I don't know where we are kind of agreeing upon on the guest side. So I ended up sticking to TSMV3 because I had that kind of hacked up, right? That's one reason.
I see. Okay.
The other thing, there are other two things that I want to bring up. One is both are kind of related. So from an ARM point of view, if you look at my patches, there is this last patch in my series which requires me to kind of, so when we have the protected memory, um, uh, we need to, with pass-through devices assigned, we need to make sure that the protected memory is instantiated, as in like, we have the memory backing pages allocated for that protected memory before the device can initiate a DMA. In the case of um, um, non-secure memory, as in like the shared memory, this is primarily done by VFIO, right? The VFIO, the IOAS map or the DMA mapping kind of make sure that, we would do a GUP, and then, we would kind of like pin the pages and then add them into the IOMMU so that the device can do non-secure device can do the transitions. But in case of protected memory, since on the ARM side, and I think on the TDX side also, the protected there is something called a secure IOMMU, or like realm SMMU in ARM terminology. So that's managed by the firmware. So we don't, the VFIO doesn't really play a role in managing that. So, so what I ended up inventing is actually an IOMMUFD IOCTL called TSM map IOCTL, which will just straight away get into KVM. So I think that's one thing we probably need to kind of get consensus on regarding. I don't know whether AMD needs that, because AMD's protected memory is still managed by the same non-secure IOMMU. And I have this vague understanding that TDX have this flow of accepting the memory, which means before even I can return a DMA address, it is guaranteed inside the secure guest that the backing pages are instantiated. Um, we don't have one such flow in case of ARM. We could invent, which basically is like the guest just going and dereferencing the memory, which will cause the page fault to happen, and the backing pages get instantiated by the KVM page fault. Or we could do the same IOMMUFD IOCTL, where I am transitioning a memory to protected. I get into IOMMUFD and call a map IOMMUFD IOCTL, which will instantiate the backing pages for the protected memory. So that's one thing I'm not sure how these three architectures would want to get consensus on.
Do you mean that you cannot let KVM to fault in the
Oh, I
private
can.
memory?
I
You
I
can,
can.
but
Yeah, I can.
so why you want to like
Yeah,
pin this
yeah. Right
like a
now
map?
I don't. Right now, I don't. The reason I don't is because there is no need to go and pin memory unless I know I have a VFIO device, right? That pre-pinning is not really needed unless I have a VFIO device. And from a guest point of view, there is no clear idea whether a pin I need to fault this in or not for a DMA address, right? If it's a non-secure device, as in like or all this pinning is done by VMM, right? Because the real work is actually done by VMM through the IOMMU, IOS map or DMA map of the VFIO. I was not sure where we want to do that for protected memory because different, and I think AMD will do the same thing for protected memory. It will come all the way to iOS. And I think TDX does it as a part of guest faulting in, as a part of accepting the memory, right, inside TDX guest.
Yeah,
So
I
I'm
think
just,
I think Jason has some suggestions on that.
correct.
Yeah, it means that his suggestion is that LMFD will not manage the secure part of the mapping of the secure part.
Yeah.
So yes, his suggestion is that we make guest MMFD to populate these private memories. Yeah.
The problem
I think
is
that's a good
this.
I think that's a good suggestion. Yeah.
Yeah, the problem is this only need to be done if I have a VFIO device. So that if VFIO device condition, how will I put inside KVM was my question. Right. I mean, all these things are needed only if I have a VFIO device, pass-through device.
Yeah. But QEMU is the owner of the device model, and the QEMU knows is there pass-through private pass-through device.
Sure.
And
At which point there will be an IOCTL on the KVM side rather than the IOMMUFD side. That's what we are saying. So instead of QEMU calling an IOMMUFD to map private pages, the QEMU will now call, if there is a VFIO device present, a KVM IOCTL for mapping private pages. Is that what we are kind
of you mean for legacy cases or what?
No, so we are now saying that instantiating or allocating the backing pages of private memory will be done by QEMU based on whether VFIO is present or not. So we are sending that information all the way back to VMM, and the VMM will now have to make an IOCTL to request now instantiate the backing pages, right? In my path set, I have implemented that as an IOMMUFD, and I think Jason is not in agreement with that. What I hear from you is, yes, we should not be doing it in IOMMUFD, but it will be good. But we can do it as a KVM IOCTL. Or are you suggesting it to be something else?
Yeah. I think we will agree on this. Yeah.
Okay.
The idea is that the private memory now the private memory management should always go through the guest MMFD, and if some vendor confidential VM requires pre-population of the all the private memories, and guest MMFD should do that.
Okay.
Yeah.
Okay. Got that. I'll take a look at that. So it should not be. So it will not be a part of TSM framework. That's what we are agreeing, right?
Yeah.
Dan, you agree? Like we will not do it in TSM.
No, I don't think but is the guest MMFD pre-population only for ARM and Intel and AMD doesn't need to do pre-population?
I think we will need to, because otherwise how will you do a DMA right? So basically the problem is the guest would do a DMA allocation and pass it to the device. When the guest is doing a DMA allocation, guest doesn't know there is a backing page or not. I mean, depending on what the workflow guest did. And the device will try to do a DMA right, at which point we don't have the translation for that address available in stage 2, right? Or the IOMMU.
Yeah. So I don't see any way for that to be anything that TSM needs to handle. It has to be Has to be through guest MMFD.
Okay. And guest MMFD, whenever we say guest MMFD, we are not looking at a guest MMFD FD based interface, right? We are saying it's a KVM octal, right? Because
No, it should be guest MemFD interface, I think.
okay, but we need a KVM instance though, right? As in like to which VM these pages has to be. Maybe there is a way. I will look at whether, FD based instantiation, like I mean, I can allocate things for guest MMFD. But I will force that into the stage 2 of the VM. I'll take a look. Yeah.
Yeah. I think actually there's already some implementations between guest MemFD and KVM. Basically, it's about guest MemFD pre-population or something.
Oh, okay.
Yeah.
I'll take a look.
Yeah.
I'll take a look.
Yeah.
If you have reference to that, and if you can share either on Discord or by mail, that would be good. I mean, I can take a look.
Okay.
Is existing feature or is there a new pre-allocated feature to guest MMFD?
Previously, this is an existing features for this pre-population, but I think now they are working on this in place guest MemFD in place conversion. They are reflecting the pre-population flow. Yeah, there's some patches on the fly. Some are related to this pre-population. Yeah.
Okay, I'll take a look. Yeah, if you can share the Zilun, if you can share the link, that would really help me rather than me getting lost in the large number of emails. Yeah.
Okay.
The other thing I also want to bring up is from the ARM IOMMU point of view, we have quite a lot of. I think that's true with other IOMMUs, right? There are these queues and tables, all those things which need to be allocated, even for the secure side of IOMMU, right? So if you really look at it from the point of view of two IOMMUs, right, even though they are just one IOMMU with a secure part and a non-secure part. So there is a secure IOMMU and the non-secure IOMMU, and secure IOMMU has quite a lot of queues, PRI queues, command queues, event queues, and then there are tables and things like that, stream tables and things like that. So there is this desire to kind of like have guest drive the allocation of pages for these queues, right? The backing memory. So basically, the same way we do the TSM do the connect for the PCI device, when an SMMU is present in the system, and when the platform knows that it is TE capable and there is a secure side of SMMU for each the real hardware SMMU or the IMMU found in the system, the host operating system, as in the Linux, we would want Linux to allocate pages and hand over that pages to the firmware so that the firmware doesn't have to pre-allocate these pages. Because depending on number of IOMMUs or the queue size or different values, the amount of memory needed for getting an operational secure IMMU would be varying, right? So what I was actually wondering was similar to what we have as connect kind of callback in TSM for the PCI device. There is a desire for IOMMU device to have a callback which is ARC specific, which can help us instantiate the way we instantiate a device with the firmware, secure firmware. We also wants to kind of do some instantiation of the IOMMU instance with the secure firmware. And I'm wondering that would be an ideal thing to take over by TSM.
But is that a per guest resource or just
no? It's a per system resource similar to the PCI device. Yeah.
So the VMM initializes and says, oh, by the way, to operate throughout in secure mode, I need these extra pool of pages for the secure MU context.
Yeah. similar to like if you look at my patches, it is
can
similar.
I ask a question? I didn't hear clearly. So see, it is the guest runtime providing of these pages, or
No.
on the TDI bind phase we could
No.
provide these pages.
No, this memory doesn't come from guest. So this is equivalent to a hardware, right? In order to initialize the hardware inside the firmware, right? Let us assume that this IOMMU is two IOMMUs, right? Secure IOMMU and non-secure IOMMU. Non-secure IOMMU is instantiated by the Linux kernel properly, everything done. The secure IOMMU is, you could at an abstract level, think of it as being managed by the secure firmware or the RMM in the ARM case, right? Or the TDX module. Now, in order to instantiate the secure IOMMU inside TDX or RMM, it needs memory, right? The way firmware could ideally do this is there is a pre-allocated pool of memory for the firmware, and the firmware can pull memory from the pre-allocated pool, right? I mean, that's how firmware would allocate memory for its purpose. But we could have systems with large number of these devices, similar to PCI devices. The reason why we didn't instantiate a PCI devices by the firmware directly is because there could be a lot of these devices, and it's not really clear how much memory we would need for the PCI devices. Otherwise, we could make the firmware iterate the PCI devices, instantiate everything from them. So there is no really need for that connect kind of a thing, right? Everything could be blindly done by the firmware. We drive that from the Linux kernel primarily because we want to have some control on what the firmware is able to do. There's a desire to have similar control on the IOMME initialization side, and similar to connect. If TSM can give a callback, which the IOMMU layer, like the PCI layer, using the probe or whatever, and then TSM connect kind of a thing. If we have something which the IOMMU layer will plug into, so that we could kind of help the firmware instantiate the secure IOMMU. All right.
But this we have this on the TDX side, is we have like we call it a TDX bus, and then there's like a TDX TSM device that can attach to a TDX TSM driver, and that so when that device arrives and it gets enabled, that's the point at which it registers this class device that can indicate whether the PCI device is connected or not. But before that happens, basically in that driver probe path of this kind of common TSM device, that's where I'm thinking it could do all the allocation of extra pages and talking with the platform IOMMU device. And I'm assuming that piece is already there.
So you are saying in the TSM probe callback, is it? We do.
Yeah, in the TSM probe callback, that would be a thing that adds the pages and talks to the architecture IOMMU driver to basically get it prepared to turn on secure. But I think that's how it works on Intel side, right, Elon?
Yeah, yes. But actually, on this phase, in this phase, the secure IOMMU driver didn't allocate all the pages. The first on this probe phase, the Intel secure IOMMU we just enabled the Intel secure IOMMU into TDX mode, so we provide some pages, and when
which is similar on our side.
Yeah.
So
and
what I was
there's
actually
other pages, when the device is to be bound to be bind, there are other requirement for the secure IOMMU to provide the other pages, like these device context pages. Yes, and that would also call back to the IOMMU driver. Yeah.
Yes. So yeah. I mean, if you have changes available in any of the JIT repo, I could take a look. I was just wondering, there's going to be a separate abstraction other than the existing TSM callbacks to do this. But if you are saying existing TSM callback is good enough, and then we should be doing the existing TSM callbacks, I can take a look.
Currently, I don't think the I have some implementations here, and currently I don't put these secure MMU configurations in TSM framework, because in IOMMUFD now we create the VIOMMU object that represents the if we mark it as a secure type virtual MMU, then this type object would take care of the secure configuration part of the MMU.
So, I completely agree. So there are two parts of the memory allocation race. One is per device memory allocation, which could be the device specific pages, something we need to allocate and hand over to the firmware. And another is the IOMMU itself, which is independent of that stream or independent of that device, right? Which could be the command queues or the event queues for the entire system, right? So, so I would assume there would be some place in the TSM framework where we allow the system-based allocation to happen and hand over to the secure firmware. And as you rightly said, VIOMMU probably is the right place to do device-specific, stream or the device-specific table allocation, right? The pages for that and hand over, which is more or less what I was actually thinking of the device side. We will probably do it at VIOMMU because there's going to be a TSM type of VIOMMU. I was not sure for the system queues where the allocation should happen. I was wondering IOMMU layer would have some equivalent TSM callback so that whenever an IOMMU driver is initializing, it will find that, oh, I have like a secure side of IOMMU and it will check for the presence of a firmware and then it will call into the TSM callback, which would allow the ARC specific thing to happen. But if you are saying that it has to happen in the PCI probe routine and TDX that's what TDX does, I can take a look at the TDX and then see if we can do similarly on ARM2.
Yeah, okay, I understand. For the system level, for the system memory configurations, for now, as Dan said, that we provide we do this secure memory configurations at TDX TSM driver probe phase.
If you have patches which kind of shows some of these details, I can definitely take a look. Right? It doesn't really need to be like complete. Like if you can share by email also, that's good.
Okay. Yeah. Actually, we don't make some general interfaces here. We just call the x86 platform operations to enable the memory.
Okay.
Yeah.
Okay.
Yeah, do we have the equivalent on ARM? Because I think the x86 platform operations are up and running, so you can basically call them. Basically, those are up and available before any driver loads. And this seems like this IOMMU and it might need to wait until the PCI driver patches.
I haven't looked at that. Probably like I'll spend some time looking at the x86 side and see whether I can replicate the same thing on the ARM side. Yeah.
That was part of the reason, the motivation for having this TDX TSM driver. It was that we could kind of delay attaching that stuff until module probing is up and it's at the end, later in the process. Oh, I see Jiwen joined. Hey, Jiwen.
Hey there. Hi. I'm sorry. I just remember that we had meeting.
Oh, no worries. I forget that there was some open topic that you were interested in talking about here, but I forget now. I forget what it was. Do you remember? If you remember, great. We can cover it as an open. If you don't remember, then that's okay.
Yeah. Originally, I at the same time interested to discuss the PQC support for the
that's right. Yeah.
IO. Mainly about the policy selection. Looking for some opinion in this forum.
do you want to throw up that slide because this is all open, like having a post-quantum cryptography policy is nothing confidential about that. Like it's kind of in the entire industry knows about this, but you kind of get some opinion about how the policy should be handled, what the policy options are.
Sure, I can briefly talk about it. Because with PQC, a device or a host may choose to support PQC or traditional algorithm. So the policy may be a TVM prefer PQC only or traditional only. A host may choose to support PQC only or traditional only. A device may support PQC only or traditional only, or both. Then the question would be how we define the policy and who will determine which one I prefer if my peer support both. For example, if a device supports both PQC and the traditional algorithm, then how the VMM tell the TSM say I prefer PQC as my first preference, and the traditional at my second, or vice versa.
Yeah.
Yeah.
Yeah, I mean, like, I mean, and I think we can imagine some policies, but at the end of the day, it's gonna be. I think at the end of the day, it's gonna be customer driven, where the customer is going to say, "I am prepared. I am prepared for post quantum, and I want to use it if it's available, or I want to fail if it's not available." But it's kind of hard for the VMM to really have a policy there because it depends on the workload and what.
When you say customer, which specific entity you think that do you mean TVM?
I'm thinking of tenants. Yeah,
Tenant means the TVM, right?
the TVM.
But there might be a case that a TVM is launched after the VMM use the TSM to establish SPDM session.
Yes.
Then the VMM must choose a PQC policy before TVM is launched.
VMM, yeah, must, but even then that becomes a deployment issue where the tenant knows, or the VMM is picked by some scheduler in the data center that says, this cluster is a PQC cluster, or something along those lines. So the VMM basically wouldn't be surprised that it has picked a policy that a tenant doesn't want, like that.
Oh, do you mean the orchestrator should choose
Yeah,
the policy?
the orchestrator would basically be like, would know ahead of time what the tenant, so the tenant would have tenants would have a policy, they kind of be flagged that way. Hosts would have a policy, and then there's some orchestrator that's matching that up and saying, okay, don't send PQC only tenants to a traditional only host. That kind of decision.
Okay.
So I think it's good to have defaults, but yeah, but I feel like that ultimately it's going to be the customer who's going to know that they need or have or need PQC, and
yeah.
And then
So this is the ID encryption part we are discussing,
this
right?
is the algorithm for ID encryption, right?
No. This is algorithm for SPDM session.
Okay.
SPDM
Yeah.
session, yeah.
Yeah, because from a device perspective, it may support a PQC certificate and a traditional certificate. When TSM establish a SPDM session with a DSM, the TSM need choose what algorithm I support. A TSM can say I support both PQC and traditional, then up to the device to choose which one
Correct.
the device will
So
pick up.
So the Lucas SPDM patches actually kind of looked at it from the point of view of which slot, which certificate chain to use, right? So we get two certificate chains and then we say use a specific certificate chain, right? So like is that same thing that so if I choose a particular, I think in Lucas changes was talking about slot, I guess. And I think that similar thing exists in AMD patches also. I remember seeing that, which is a module parameter on the AMD side. So if I select which chain to use, will it automatically select which algorithm to use?
Oh no, you can only select which so first both host and the device need to negotiate. We call
Mhm.
VCA, choose the version, capability, and algorithm. So algorithm is chosen before you indicate which slot you want to use.
Mm.
It's in a VCA phase. It's very early phase, even before
Okay.
you choose the slot. Slot just means you probably want to choose which one is your authority. For example,
Okay. Mhm.
yeah, the device could say the device manufacturer's authority, or some OEM is authority, or ODM is authority. It's a
Mm.
it's a different topic from which algorithm you want to choose.
Okay.
Yeah, that's
Mm.
why I think it's a broader open that how we determine the policy. Because from TSM perspective, the easiest way is say I support both. You just pick up, but it up to the device to choose if the device support both PQC and traditional. Maybe a
So
device. Uh,
yeah,
was-
sorry, go ahead.
I say maybe a device choose PQC as a first priority if the TSM support, then the TSM, if the TSM always support PQC, then the device will always support PQC as well. Then there's no chance for that the TVM to say I probably only support traditional. How I can make that happen?
Mhm.
That's
So
why we
from
need
a
some kind of
yeah,
policy.
from the interface point of view, we are looking at during the TSM connect phase, when I map it to the TSM existing TSM, during the TSM connect phase, I should be able to say while instantiating this device into the secure firmware, I should be able to say which algorithm to use. Is that what we are hinting at? So that we
When you say I'm going to say who is I,
Linux kernel, non-secure Linux kernel, the hypervisor, non-secure hypervisor, because we
oh,
have this,
hypervisor.
yeah. So we inside Linux kernel hypervisor we have sysbus, PCI, TSM connect.
Yeah,
Now when
the hypervisor. Yeah.
yeah, so while doing that connect operation, you are saying we should also be able to say which algorithm to use, so that we set up the SPDM session with the right algorithm.
Right. At least you need to pick up. Do you prefer
Okay,
PQC as first priority or
okay,
traditional as
okay.
first priority?
Okay. Okay.
That gives us a chance if both TSM and DSM support the PQC and the traditional,
Mm,
then
mm,
they have a
mm.
chance to negotiate the traditional.
Okay. Got that. We don't seems to be having any such thing on ARM side. I'll take that feedback. But yeah, but I think on the TSM framework also, Dan, we don't have anything. Like there is nothing like that.
Yeah, it's just added in SPDM 1.4 in May this year. So I think it's a new topic. Yeah, if we can get some feedback and we can discuss, that'll be good.
But I'm assuming that this is probably something that's being discussed in another confidential forum, not but the general concept of of Linux needing to have a knob that might need to set a policy, because when you have the choice, I mean, I think at least from our side, like from the kernel side, we just need to have a knob that says, oh, by the way, if there's a choice between options, we can probably default. We'd probably default to the least surprising thing. The least surprising thing with that is that everybody knows how to speak traditional, and then have an override that allows us to force PQC if we need to. Something like this, but it's probably just another SysFS knob that says, oh, by the way, when you do connect, please use PQC.
Yes, Dan, you're absolutely right. The traditional could be our default policy today, but after 2030, then the PQC become a requirement. when we need to choose to PQC as a default at that point of time.
But I think that's a default value that we, for at least with Linux, we push that problem out to the distributor. So Red Hat or SUSE or whatever cloud vendor distro, they can make like whenever there's a choice and you ask the kernel people, all we're going to say is, oh, we'll just kick that option down the road to somebody else to decide. So the distributor gets to pick, or CS cloud provider gets to pick the policy. Yeah, so I think so between a PQC knob and a nonce, I think we're good.
Okay.
But yeah, so I like the idea of doing the connect first, but also I like the idea, I like that you put the entire ARM CCA flow out there, and you Luna. I think I want to do that as soon as we can on the for the TX Connect side, but I think if we can get the TX connect path and the ARM CCA connect path, and then do a looser version of the stuff for the IOMMUFD stuff, I think we can put that first phase to bed and get it signed off by Bjorn and just say, yep, connect is done, and then we can start focusing on the IOMMUFD and VFIO pieces.
Yeah. I'm now working on the so-called link part of the TDX Connect implementation.
Okay.
Yeah.
Are you? I'm wondering, like Anish, and so Elon, your stuff is, you got the stuff based on V4 now of the PCI TSM?
Yes.
Working on that?
Yes. I have already rebased on the V4. Okay.
Anish, V3 is pretty close, and I just did the V4 rework. Do you want me to take a look at rebasing on V4, or you're already working on that? Or?
So I can rebase on V4. The only challenge is what will be the equivalent of bind unbind, right? I was not sure. So if I get equivalent of bind unbind and guest request, I can rebase that.
Is ARM CCA going to support a mode of just like we think we have some customers that are okay with, like, basically there's some value in just being able to have IDE encryption.
Oh yeah, that's also there. Yeah, absolutely.
So I'm wondering if we just yes the bind things aren't there, but basically say, like, let's cut a branch that can do IDE encryption for ARM and Intel, and then get that signed off by Bjorn, and then move on to the, because I think as long as that's kind of mushy.
Okay.
Yeah, get that solid, get Bjorn sign off, and then we can kind of stand on solid.
The only thing missing for me on the bind side, on the connect side right now, is the SMMU details, which we discussed, IOMMU details.
Okay.
So if I can see a similar implementation on the Intel side, I can take a look and then kind of
Okay.
see what we need to do. But I think we can do that. You know, but my entire testing stack is a full stack, and that's why I kind of insist on. I mean, even if the bind unbind guest request changes, I'm okay. Like I can throw
Okay.
away and implement. But in order for me to kind of run the full test, I need a bind unbind and the guest request to get
Okay.
the entire. So even if we have like a not so clear design, I think including these two, right, as in V3, right, is
Will help you.
useful. Yeah, yeah.
Okay.
Useful.
I'll take a look at extending, do some extension patches on top of V4 to help you out there.
Thanks.
Okay, so yeah, I think maybe it's that your next version of ARMCC and my version of TDX Connect would focus on the connect part. Forget about the bind unbind at the moment.
Yeah.
Yeah, but
Okay.
but I'll also include a couple of patches just to add the operations that Anish can add on top. But yeah, but basically we'd have a pretty clear cutoff point in the series where it's just two vendors can do IDE through a TSM is the goal.
Yeah.
But so the other thing that was a surprise to me, which is fine, and this is something I mentioned in the cover letter feedback, was you're using KVM tool to validate this, and that's fine. And maybe we should be using KVM tool, but like there was like, especially on this whole idea of device enters in shared mode and then switches to private mode, and when it's in shared mode, you might need to handle DMA versus kind of page conversion, all that stuff. We had a lot of work done on QEMU side for page conversion. I've never looked at KVM tool, so I actually don't have a preference either one of those. But in terms of like being able to test these three vendor solutions,
I do have some restrictions with respect to QEMU,
okay.
so that's why I end up using KVM tool.
Okay.
But yeah, all what you mentioned works on KVM tool, and I did push a branch. There is no special command line options, like you just it needs IOMMUFD, VIOMMU, and VDevice. That's all. So you just need to use everything else, and KVM tool is not of that it's not a production quality VMM, right? So it's much simpler shortcut kind of a thing with respect to its options and other things. So
that's attractive to me. Like is it being able to say like, hey, here's a KVM tool. It tests all the ABIs, and if somebody wants to do a KVM version of it, they can. Like maybe
that's what we essentially do. Yeah, and in case of most of the work that I'm doing, the ARM kernel team does the KVM tool part, and the Linaro does the QEMU part.
Okay. Does Lennar want to do some x86 QEMU too?
Sure, yeah.
That's a different call, but no, I think it's interesting, and at least for me, like I haven't touched
KVM tool is very simple. Actually, I have only 3 patches to get the entire thing working in KVM tool. I did share the repo link, so you can look at the top 3 patches, and it's very simple, nothing fancy.
But does KVM tool handle page conversion?
Yes.
I don't know. Like you're making it sound very, very attractive. Like,
yeah, but it may not be with whatever. It may not be like the full-fledged like the QEMU has this object hierarchy, QOM model, and all those things, right? Here it is much simpler, right? I mean, it has got a callback which says like so memory fault exit will come to a callback, and you do whatever you want there, right? Kind of thing, right? It doesn't do other tracking and object hierarchy, nothing. So there is a function which gets called with memory fault exist, and then say, like, you do conversion from shared, like, set memory attributes of KVM and things like that. It's much simpler that way. KVM too.
But when in shared mode, it's you're able to do bounce buffering and all of that.
Yes.
Yeah. Okay, yeah.
And the bounce
let me
buffering
check
part
this
is done by the kernel, as in like SWIOTLB. We kind of
out. Right.
force SWIOTLB, but from the KVM tool point of view, it doesn't really like. The only thing for the device it needs to do is VFIO needs to kind of map unmap things correctly, and it doesn't have like VM. It just pins. It just maps everything. I mean, for a normal KVM tool VFIO, the entire guest memory is mapped in a go. Like there is no VFIO, IOMMU, or things like that.
Okay.
So it's much simpler.
I wonder how far away it would be to boot a TDX guest with KVM tool if that's a. I don't think anybody's tried it, but that does sound attractive. So somebody asked me like, well, like what's the production use case for KVM tool? I'm like, well, I think it's kernel development.
Yeah. I think that's correct though from our side.
Okay. But that's yeah. So that sounds like a plan. Yeah, like you learn to show the TDX Connect example. Me to add those bind APIs just back on top, just so Anish can do his full end to end, and then we wrap it up and say, look, here's Intel and ARM,
Bind,
and Bjorn, please.
bind and guest request both, right? Bind
right,
and
yeah.
guest request.
Right,
Yeah.
guest request, yeah. Yeah, Elud asked me that too. He's like, "You dropped my guest request patch." Like, I know, I was just... so both of you noticed that. So I'll put it back.
Yeah.
I'm actually not sure how we could have some offline chat. You just mentioned that we use the Discord, but
Yeah, I am on Discord.
I'm not familiar with this. I'm searching for how we could use that for communication.
Did you not get? So I mean, so here's the. I'll put it in the Zoom chat, but I don't know if how long that chat will stay active. But
yeah,
can you?
I can see there's a meeting chat, but I'm not sure if the meeting is ended. Is
No.
it still no? Okay.
Oh, I don't think so. But well, so copy this link. I just put it in the chat now and use that to join. I could have swore you've been invited to that before.
Discord.
Yeah, but yeah, I hang out there. Alexi hangs out there. It's pretty quiet though, but yeah, we can. But I hang out there and feel free to ping. And Dave quickly if you want to join that too. No worries.
Yeah, I think I will. It's a good way to keep track on things.
So you based your attestation pieces on top of Lucas's, and I think this is another reason I was going to kind of slice up the upstreaming is that we don't, if we just do like KVM tool to get a device through the connect phase and the bind phase, we may not need the we can bring in the attestation piece after the fact. It doesn't need to be built on top of that branch, which I think is still kind of in flux.
Yeah, I don't think anyone's looked at what the TVM would look like.
Yeah, so we have Lucas's thing, then we have Lucas's new thing, which he hasn't done, with the netlink, and then we have Alexi has his SysFS thing. So that piece is still kind of up in the air for me. It's like let's work on other things that are not so mushy.
I think it's also still up in the air what the idea is. What is going to end up being actually consumed by the TVM is going to be something that comes from the TSM, not from the SPDM session directly, right?
Right. Yeah. It's
going to interface to the TDX module that says, "Give me a device report," and then that's going to be in a format that's not necessarily SPDM. It's going to wrap it and do other things, or it could be internally converted from SPDM into something like CBOR to be handed over. Any number of things right now, but
right, yeah, and every time we've asked this question at a conference, somebody's had a different idea of what it's supposed to be, and so that's the it needs to focus attention, but until then, I feel like until we get to that point, yeah, we have a lot of other things, fish to fry, kind of in the meantime, or things to deal with.
Mm-hmm.
Okay. That sounds like a plan. Any other? Steve, we're at the top of the hour. Any other questions, concerns? Yeah. So, but yeah, Elun, let me know if you can't get on the Discord. We can try to figure it out. But
Yeah. I'm already in this Discord chat.
Okay.
I'm not sure if Anish is in this chat.
Anish is
I'm
here.
not sure what's his
Yeah, KV
IDs.
Anish. Yeah, I'll ping you.
Okay. KV Anish. Okay, I
Yeah.
see.
Cool.
I just pinged you. So I did share the command line option I am using for KVM tool. So there is nothing fancy
Okay. Yeah. Right.
on the meeting chat. Just I don't know if you
Oh,
there
let
is
me-
nothing fancy there. Yeah.
Okay.
Yeah, okay. Test.
Cool. I captured that. Okay. That's all I had. Thanks for joining. Good. Have a great rest of your day, and David and I can go to bed now.
Have a good
Thanks
night.
guys for staying up
Okay.
late. Thanks.
Yeah. We'll see you.
Bye.
Bye.
Okay, bye.